Hi everyone, let us try to solve one question regarding the synchronous counters. So they are asking for design a synchronous counter for the following using T flip-flops and D flip-flops. I mean, first one is T flip-flop and the second one is D flip-flop. Okay, fine. So let us do with first T flip-flop and we'll go with the second one, that is D flip-flop. Okay guys, basically when you are trying to solve any kind of synchronous counter, if you remember the earlier various procedure, this procedure you have to follow, right? And what is the first step? You have to identify what kind of flip-flop it is, right? So they have mentioned clearly you have to use the T flip-flop. So we'll go with the T flip-flop. So first step is done. The second step is, for the T flip-flop you have to know the excitation table, right? So the excitation table is, if you go with the T flip-flop, basically if you are going to have the present state as Q1 and next state as Q1 plus 1, 0 0 0 1 1 0 1 1 are the combination, and T value will be latch mode, that is 0, and 0 1 is changing mode, like complement, and 1 0 is complement, and 1 1 is the latch mode, right? This is the corresponding excitation table. And the next step is you have to go with the state diagram. Guys, actually before going to define something, right, they are not saying here you have to follow up counter, you have to follow down counter, you have to follow either up or down counter, like that. They haven't mentioned anything, but they have mentioned in the form of this format, right? This is the question they have given, meaning that they have to get this sequence, right? From 0 0 it has to go for 0 1, 0 1 it has to go for 1 1, 1 1 it has to go for 1 0, 1 1 1 0 it has to go for 0 0. This is the requirement they have mentioned clearly, right? So this is actually the given question. So for the question itself a kind of a state diagram, so we need to draw the state diagram for it. But the next thing is you have to write down the circuit for the excitation table, right? Circuit for the excitation table is, you have to take out the present state and you have to take out the next state, and you have to find out the excitation table for the respective T flip-flop, right? Yes. So here you may get question, right? So the question is, which one is what value and which one is the what value, right? So you may assume this one as Q1 and this will be the Q0, right? Yes. If it is Q1 and Q0, so let us go with that procedure. If it is Q1 and Q0, this will be the Q1N and this will be the Q0N, right? So 0 0 0 1 1 0 1 1 1 1, right? What will be the next states? If it is 0 0 it is moving to 0 1, if it is 0 1 it is moving to 1 1, if it is 1 1 it is moving to 1 0, if it is 1 0 it is moving to, if it is 1 0 1 0 it is moving to 0 0, guys, right? If it is 1 1 it is moving to 1 0. I hope you understood, right? If you have any doubt you can go through the earlier videos. Right. Next you have to note down the flip-flops, right? One is they are asking for T flip-flops, right? So one is T2, another one is T1, right? So T1 you are going to get, so let me call this as T1 and T0, because it's not a kind of compulsory according to notations, right? As I have taken the Q1 and Q0, you can go with the T1 T0 better to avoid the confusion, right? So T1 0 0 latch mode, 0 1 complement mode, 1 0 complement mode, 1 1 is latch mode. Okay, fine. What about the T0? T0 is this is complement mode, latch mode, and this will be the latch mode and this will be the complement mode. Yes. So once we define the T1 value and T0 value, what is the next step? You have to derive the expressions for it, right? So if you go with the expression of T1, simply go with the K-maps, or you can directly go, right, as it is simple one, but better to go with the K-maps, right? So if I take Q1 and Q0, this 1 1 you are getting because of 0 1 and 1 0, 0 1 and 1 0, 1 0. So you cannot able to combine any manner, so you can able to take out the individual, right? So T1 will be you have to have this one. This first, if I write this one will be q1 q0 bar plus q1 bar q0. This is t1. What about the t2? T2 will be why I am getting T2? This should be T0. This should be what, like this 0011. For 0011 you have to have, right? So 0011 here these two have, right? So if you remember, this value is q1 bar q0 bar, this is q1 q0, right? So if I say simply this is XNOR q1 q0, this will be the XOR. So T1 is XOR, T0 is XNOR, right? So with this, can we able to go with the circuit diagram? Yes. So the next step is you have to go with the circuit diagram, right? If you go with the circuit diagram, we are going to have one T flip-flop, another T flip-flop. So they are going to have synchronous, right? So they both have the same clock, that's good. And this will be the T0 and it will be the T1. So it is going to produce Q0 bar, Q1 and Q1 bar, right? Yes. Now what might be the T0? T0 will be Q1 XNOR with Q0. Q1 value you have to get. Yes, Q1 value I got from here, and you have to XNOR with the Q0. Right? XNOR means you can have a kind of bubble, right? Yes. What about T1? T1 is XOR with the Q1 and Q0, right? So Q1 Q0, you have to make sure to have XOR operation. That's it, right? So this is the corresponding diagram for synchronous counter for the given requirement, right? Yes, that's good. What about the second way of the requirement? Second requirement, it's a single line. Right? So the second one is the same question you have to extend for D flip-flop also. So they said already it's you have to use for D flip-flop, and the second step is you have to write down the excitation table for the D flip-flop, guys. What might be the excitation table for the D flip-flop? If I say the present state is Q1 and next state is Q1 plus 1, if it is D flip-flop, if it is 0 0 0 1 1 0 1 1, so its state is 0, this is 1, this is 0, this is 1. Okay, fine. So then you have to go with the state diagram they have given already, and you have to draw down the excitation table for it, right? So the step here is state diagram they have given, you have to write down the circuit excitation table, right? So what I can do now, so I will try to go with the same table extension here itself. It's better to avoid the time taken. So I can go with the flip-flop, where this flip-flop is a kind of D flip-flop. So this is D1 and this is D0, right? So try to avoid this one. You have to go with this for the previous question. Yes. So D1 will be you have to think about these two terminals, right? 0 0 0 1 1 0 and 1 1. But if you are able to observe clearly 0 0 means its value is 0, 0 1 its value is 1, 1 0 its value is 0. Okay, so for D0 you have to go with 0 0 0 0 is 0, 0, so 0 1, right? 0 1 you have to go with for 0 1 you have to go with 1, for 1 1 you have to go with 1, for 0 0 you have to go with 0, for 1 0 you have to go with 0, guys. So these are the two values. So one is D1 and another is d0, right? So now try to simplify it. So to get the value of d1, go with the k maps q1 and q0, 0 1 0 1 and 0 1, right? Yes. So what might be the values of these ones? One is 0 1, another one is 1 1, 0 1 and another one is 1 1, right? For these you are going to get the value, right? If you try to solve this one, you are going to get simply d1 equal to q0. Am I right? Yes. Similarly, go with d2. Why I'm getting d2 again? d0 0 1 0 1. So we are going to get for 0 0 and 0 1 you have to write. For 0 0 and 0 1 you have to write. This would be d0 equal to, I think, q0 bar. q0 bar or q1 bar. So if I take this is q1 and this is q0, this should be q1 bar. Right? So as you know the values of these d1 and d0, you can able to simply construct a circuit diagram for it, right? Yes. Take out the d flip-flop, and as they are synchronous, you have to apply the same clock signal, and this is d flip-flop d0 and d1. Output will be q0 and q0 bar, q1 and q1 bar, right? So d0 you are going to get from q1 bar, and for d0 you have to place q0. For d1 you have to connect q0, right? Yes, this is the corresponding synchronous counter for the given state diagram using d flip-flop, guys. Okay, I hope you understood clearly. Thank you.